So in this video, we're going to create an LED circuit using the Raspberry Pi, and this is the first lesson for Chapter 6 in the Beginner's Guide. So we're going to need a female-to-female jumper lead, and you're going to want two different colors of those. So a dark color for the ground and a light color for the power. You're also going to need another light colored jumper lead. If you've got two that are white, that would be ideal. But I've got two light colors. Those will be for power, and then a dark color female-to-female jumper lead for the ground. And then you're going to need an LED and resistor. I'm going to use the 220 that came with the LEDs and jumper cables from our Freno kit. But if you have anything 330, as close to 330 as possible for your resistor, that would be ideal. So we're going to start by connecting our ground pin, which if your Raspberry Pi is facing you in this position, then the first ground pin is going to be the third pin down. Right, so that will be my ground. And I'm going to connect that ground to the negative leg of my LED. So LEDs have a short leg and a long leg. The long leg is the power, and the short leg is where we're going to put the ground. So that'll be connected to the short leg of the LED. And just give it a little push until it's in there nice and solid. Okay, now we need to, now that it's connected to ground, we need to send power into the LED, but we don't want to send a full 3.3 volts of power into it, or it might pop, so we're going to need a resistor. Okay, so we're going to take one of these resistors from the 220 pack. Okay, and one end is going to go into the female side of a light colored jumper lead, and you may have to wiggle a little bit to get it to slide in there as tight as possible. These are pretty thin wires on these resistors. They're easier to use with a breadboard than a jumper lead, but we'll make it work since that's what we've got. Okay, so I've got that in the end of my female-to-female lead, and then I'm going to put the other end in another female-to-female lead. Okay, again, just gently kind of wiggle that around until you feel it slip into the right position. Grab. Okay. So now I've got a resistor in between the two light colored female leads, and the resistors don't have polarity, so it doesn't matter which direction that resistor is facing. It's going to interrupt the current either way. So one end of that wire that has the resistor in between is going to connect to the positive leg of the LED. So we'll slide that in there. Oops. There we go. And then this side is going to be connected to a 3.3 volt power pin. And that would be our first pin in the corner of the first row. Okay, and since my Raspberry Pi is turned in, I've got my LED lit up. Okay. So that is really only using the Raspberry Pi as a power source, right? Sort of like a battery or an outlet, if you will. We're not controlling the LED with any code, right? It's either on because it's connected to power, or if I pull that power out, now it's off because the power source is off. Okay. Now, before we look at how to code this using a GPIO pin, I want to show you how to use the breadboard instead, because that makes this process a whole lot neater to work with. So I'm going to unplug all of these pieces here and set them to the side. And if you, from your Freenode kit, if you grab your breadboard that has the extension board attachment snapped on there, okay, and I've got the ribbon cable connected to the extension board, and I'm going to now plug the other end of that ribbon cable onto my GPIO pins. Okay, and you want to make sure that your pins are lined up, that nothing is bent when you snap that into place, because they can be fragile and break off. Okay, so now I have the extension board plugged into my breadboard. Okay, and hopefully you can see here that this is a nicer interface to work with because the pins are each labeled with what they do. So whatever you see a GND, for example, right, here's one, and here's another one, right, there's one on the other side. Those are all ground pins. Okay, so if I grab a jumper wire that is dark color for ground, I'm going to use black, and you want a male to male jumper, I can go from a ground pin. So for example here, now I'm plugged into a ground pin, and anything on that row is going to be ground. So it doesn't matter if I'm in the first spot adjacent to it or if I slide one spot over, right, I'm still on that ground rail. There's a little strip of metal in there connecting those together. So I want to be at a ground pin, and then along the edge of this breadboard there's a red line on the outside edge. That's where I plug in power, and a blue line on the inside edge, that's for ground. So I'm going to go ahead and come over here to the blue side. Right, and it doesn't matter which blue you slide into, it's just going to create a whole column, a whole vertical column that is ground. Okay, so now I've got a ground rail along this blue column. I'm going to also want a power rail. So if I take my light colored male to male jumper, I'm going to go from a power pin. So here's a 3.3 volt power pin. Okay, there's another one up here at the top. Right, there's a 3.3 volt. There's two 5 volts over here on the side toward the top. But my power pin I can plug into a power rail. So any of these side columns that are red, right, those would be where I can access power. So I'm going to go ahead and go from the 3.3 volts over here to the red power rail. Okay. Now in my circuit, I need to have power that's going from or into this resistor before it reaches the LED. So if I go from any of these slots on my power rail, the red column, right, I can plug in that resistor from a red to any one of these rows. And now I have a resistor going between the power and actually I'm going to jump down to row 35 so we can use that as a reference. So I have a resistor now that is going to interrupt the flow of power here from this red column, and it's going to lessen the amount of electricity that comes through. And then I've now turned on power to all of this row 35 on the other side of that resistor. So I'm going to take my my LED here, and remember the longer leg is the one that is positive that we need to connect to the power. So I'm going to go ahead and go from right next to that resistor, right? I'm going to plug in the leg of my LED on that same row. Okay, and now the other leg of my LED needs to go to ground. So if I remember the blue rail here was ground, since these are pretty long, I can stretch over to reach the ground. And, oops, that's it. And as soon as I hit the ground, now my LED is lit up, right, because I've completed that circuit. Okay, now for the Raspberry Pi to control the functioning of this LED, I need to, instead of sending power directly into the LED, I need to control the power that goes in using a program instead. So I'm going to remove my power source here, and instead of going from power, I'm going to use one of the GPIO pins. So if I look here at, for example, in this bottom corner, it says GPIO 21, right? If I go into that pin, okay, and then I'm going to send that GPIO 21 now over to a row on my breadboard. So I'm going to jump from GPIO 21 to row 35 on my breadboard. Okay, and again, I want to have my resistor interrupting when the Raspberry Pi tells that to turn on. I want it to go from that row 35 to another spot there on row 35. Okay, and I'm going to move my ground wire now so that I can get over to the other side of this. So I'm going to send my ground into this blue rail on this side, just to give myself a little bit more room. Okay, and then my LED, the long leg of the LED needs to go from power, which is in my row 35, to the ground, which is going to be the blue row on this side of my column. Okay, and that LED is not lighting up right now because I'm controlling the flow of the power through GPIO pin 21. So nothing's going to happen until I tell the Raspberry Pi to turn on the power to that pin. And then it'll send the power through this circuit that I created. Okay, so now in Thonny on my Raspberry Pi, I'm going to use Python to control this LED. So I'm going to start by importing the GPIO 0 library so that I can control these GPIO pins. So from GPIO 0 library, I'm going to import the LED function. And I'm also going to grab the time library here and import the sleep function so that I can put a delay on my LEDs. Now I need to pick a variable name for my LED. So you could call it whatever you want. I'm going to just call it LED. And then I'm going to call that function. And the pin number goes as the parameter in that function. So I chose pin number 21. So I put a 21 in there to tell the computer that I want maybe I'll make that a Y LED since I used yellow. That way if I want to add more color LEDs later, I can. Okay, now I'm going to want to turn my LED on. So I'm going to use the function, oops, I called it yellow LED. I'm going to use the function on. Okay, and that will power the LED when I run this program. So I'm going to hit run and save my file. Oops. Okay, and now I'm going to grab that LED. So hopefully you can see. There it is, all lit up. Okay, so now that it is turned on, I want to modify my code so that I can make this LED blink. So I'm going to need to alternate between on and off. So I'm going to put this inside of a while loop. So while true. And then I need to indent so that this turning it on is inside of the loop. Okay, then I'm going to have it turn off. So YLED.off. And if I were to run it like this, it's going to turn on and off alternating so quickly that it looks like it's always on. So that's why we imported this sleep function from the time library so that we can pause how long it stays on and how long it stays off. So I'll start at 0.2. And that should give us a pretty fast blink. So I'll hit run, and now if we do this over here, you should be able to see that the LED is blinking.